All right, hi everyone. So this is Notes 1. We're going to talk about just a quick review of bonding and then an introduction to Lewis dot structures as we go through. So we're going to have embedded questions throughout this, so make sure you listen carefully, think, and then answer. Here's the first review question. Which box is describing a covalent bond? A, nonmetal atom steals electrons from metal atoms to create positive and negative ions. Or B, nonmetal atoms share electrons because neither one is strong enough to steal it. Correct answer there is the covalent bond is where they share, okay, with each other. Because remember, their electronegativities are about the same. All right, how about this one? Which box is describing a covalent bond? So which picture? Correct answer there is this one, right? Because it's, the one on the left, you have one electron being taken, you get charges forming. The one on the right, remember, covalent, there's no charges, they're just sharing. You remember how to figure out how many valence electrons? So if we're looking at carbon there, how many valence electrons does it have? Remember, valence electrons are the electrons that are on the outermost energy level. Correct answer here is 4. So remember, it's what column it's in. We skip the transition metals there in the middle. So carbon has 4. Now this is super important because you're going to use this for a lot of these Lewis dot structures. So this concept of just, whatever element we're talking about, just find out what column it's in, and that tells you how many outer electrons it has, or valence electrons. So Lewis dot structures were kind of developed by this gentleman here as a way to show those valence electrons and how they interact in a bond. So those outer electrons, those are the ones that are getting stolen and shared and all that, right? We just kind of want to see how they interact with each other, and that's how molecules will form. So a Lewis dot structure is a simple way of showing that, so we don't have to draw those Bohr models, right, with all the different rings, and that'd be a lot of extra drawing. So Lewis dot structures are a way to kind of simplify that process. Now, once we can do this, and here are some examples up on the left here of what a Lewis dot structure would look like, it allows us to determine the shape of a molecule. And that shape is super important because it will help us figure out how molecules would interact with one another. So you can see these up here have different shapes, and guess what? You're going to be learning those. All right, so if we're talking about an atom, right, like a single atom, how would we do a Lewis dot structure for it? So here are your rules as you go through. So I just have element X. So we just have an X there. So you're going to write whatever the symbol is. So if it's carbon, you're writing a C. If it's iron, you're writing Fe, etc. Okay. The second thing is what you want to do is look at your periodic table and see how many valence electrons it has. Remember Lewis dot structure, that's all you're including, just the valence electrons. None of those, the inner energy levels and none of that stuff. So just those valence electrons. Okay, what you're going to do for just a single atom, right? If we have an atom and we want to see what its Lewis dot structure looks like, you put those first 4 electrons on each side of the symbol. So if it has 4, you're going to pop it on each of the 4 sides. So you can think of it like north, south, east, or north, east, south, and then the west, right? Or 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. You can put it on the 4 sides. We're never going to put Lewis dots or dots for a Lewis dot structure. They're never going to be on the diagonal on the corners. They're always going to live like on the 4 main sides. Okay. Now the electrons are negative, right? So that's why we repel them. That's why we kind of have them be on those outer edges because they're negative and going to repel each other. So that's how we represent that in a Lewis dot structure. Now, if you have more than 4, what you're going to do then is pair them up with the first 4. Okay, so for example, if I had 5, it would look like this. I'm going to just start partnering them up. Okay, 6 is going to go there, 7 is going to go there, and 8 is going to go there. Now, you may have seen when we did Bohr models, sometimes when we draw Bohr models, we did this, right? Just to kind of keep it clean and neat. So it's kind of like a nice little intro to how you do Lewis dot structures. So let's go ahead and try this. Okay, we're not going to draw anything on here, but what I want you to do is you're going to kind of look at our question and see if you can answer it. So what would the Lewis dot structure look like for hydrogen? Remember, first figure out how many valence electrons it has, and then where would you put it? Okay, what you should have had is something like this. Now, if you put your dot off on the side or the bottom, that's fine. It doesn't matter where. You got 1 valence electron, so as long as we put it on one of those 4 sides is all that matters. All right, what about phosphorus? I've got it highlighted there for you. All right, this is what you should have here. It has 5. So look, it has 1, 2, 3, 4, 5. So phosphorus is right here. So it's in that 5th column. So it has 5 valence electrons. So when we draw these in, what does it look like? 1, 2, 3, 4, and then the 5th one. Okay. How about calcium? 2, right? So again, if you went top and bottom, that's fine, or side and side, that's fine. But you just have 2, so that's what it's going to look like there. Okay, how about argon? There you go, 8, right? So this is a noble gas, right? So it's got a full valence shell. And there we are, 2, 4, 6, 8. So it's filled up on the outside. Chlorine, 7, right? Again, if you have the single in a different place, that's okay, right? As long as you have 7 total, that's what is important. And aluminum. How about that? Okay, so 3 of them. Again, arrangement, as long as you have it on the top side, bottom, etc., don't have any on the diagonal, you're good to go. All right, now, which one of these is the correct Lewis dot for hydrogen? They're all correct. Okay, kind of a trick question there. Hydrogen just has 1 valence electron. So again, it doesn't matter if we made the dots really, really big there, and I'm normally not that big, but it doesn't matter if you put them on the top, the side, or the bottom as you go through. How about phosphorus? Okay, correct answer there is this top left one. It's 5. Now, these are clearly wrong because they both have 3, but look at these 2 right here, okay? This is incorrect because when we're doing it for just the atom, remember what we said, we have to kind of go do the 4 sides first and then double up. What this student did is they went 1, 2, 3, 4, 5, okay? So this student did it correctly. They went 1, 2, 3, 4, 5. Okay, so this is the correct answer up here for that one. How about chlorine? Okay, 7 is the correct answer. Again, this one has 8, so that's wrong. Okay, can't be this one. This only has 6, or I'm sorry, this has 7. But see how these are kind of randomly drawn around? That's incorrect. Okay, so we're always going to kind of partner up like this as we go through. Okay, so unpaired or lone electrons are the ones involved in the bonding. So if you have ones that are partnered up already, that means that they are not going to be bonding with another atom. But if you have a single electron by itself, it means it can bond. So if we know that, look at calcium. How many single bonds can it form? How many spaces does it have where it can connect to something? 2, right? I mean, it's got the 2 there, 2 open ones, so that one's good. How about chlorine? Yeah, just 1, right? Because it has, those other ones are, if they're paired up, remember, it's kind of like it's a closed gate at the airport. But chlorine has 1 open one. How about phosphorus? 3, right? So not up here because they're partnered up already, but it has 1, 2, 3 places where this guy can bond. Now, if we're going to go to molecules, okay, so that was just for looking at an atom, right? If we're just looking at phosphorus, for example, what if we add like multiple atoms together and we want to make a Lewis dot structure for some type of a compound or a molecule? Now there's rules. Now there's several ways you can do this. Okay, there's 2 methods. We're going to kind of focus on 2 of them. We're going to intro one today and go into the second method a little bit more. So the separate atom method is what we're going to cover today. We'll go through. The atom electron inventory method we'll talk about in notes 2. Okay, that's actually the better method. So we're just going to kind of intro this first method so you can kind of see how it works. Okay, so let's practice one. If we're doing this separate atom method, again, this is method 1, and this is not really the preferred method, but I think it's good for you to see how it works. Okay, so let me just kind of take you through this. The first thing I want to look at is I've got nitrogen here. So for that, I've got 1 of them. So I'm just going to put that guy right in the middle. There's nitrogen right there. Now I look at the periodic table, and nitrogen has 5 valence electrons. Okay, so I'm going to put 1, 2, 3, 4, and then 5. Sorry for my really kind of chromy little dots there. So that's nitrogen, right? Now, the next thing I'm going to do here is I have 3 chlorines. Now, look here, right? How many open spaces do I have? I've got 1, 2, 3. Well, look, I've got 3 chlorines. So guess where the chlorines are going to go? It's not going to go up top here because that one already has 2. So I'm going to put a chlorine here. And I'm going to put a chlorine down here. And I'm going to put a chlorine here. Okay. Now I need to draw the dots for chlorine. Now, again, how many valence electrons does chlorine have? look at the periodic table, you'll see it has 7. So the first thing I'm going to do here is I'm going to connect it, right? So there, now I've got like my partnership, right? Right there, and chlorine has 7. So that's 1, 2, 3, 4, 5, 6, 7. Notice that I'm still doing the top, side, and bottom deal. Okay, so there you go. That's what it's going to look like as we do that. So what are the rules that are kind of affiliated or associated with that? You're going to write the Lewis dot structure for the central atom first. Okay, it's usually listed first, and if it's carbon, it's always going to go in the middle. Hydrogen will never be in the middle. Okay, peripheral atoms are going to bond up with those lone electrons. They're going to find that open space, and then you add all those peripheral atoms around, surrounding to the outside. There's 3 rules in Lewis dot structures to always check. Okay, number 1, the total number of electrons has to equal however many valence electrons you have in total. So remember, nitrogen we said had 5, okay, and then each chlorine had 7, right? So I had 7, 7, 7, so that's 21, and then 21 plus these 5, I should have 26 total. So you just count to make sure you've got that correct amount. So I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay, so that rule is good to go, right? So I'm square there. The next rule is the octet rule. Okay, every atom has to have 8 around it. Octet, like octopus, octagon, has to have 8, right? So if I look at these, look, nitrogen here, does it have 8 electrons around it? It does, right? So if we look right there, boom, it's got 8. Now what about the chlorines? Okay, now these are shared, so they count. So look, this chlorine also has 8. There they are around the outside. And then lastly, this chlorine has 8, and then these guys have 8. Okay, so the octet rule is met. That's the number 1 mistake students make, is just make sure that your octet rule is being met. Okay, so octet rule, good to go. All right, then lastly is there's no lone electrons. You can't like have a single random electron all by itself. Okay, so this one doesn't have that, right? So that means that we're good to go with that rule. So those are the 3 rules you got to make sure that you're good with as you go through these. Okay. All right, so look at, for the nitrogen trichloride, okay, total number of electrons, and we just went through this, right? 26, and it has 26, so it's good. Octet rule, right? You got 8. Now, of course, in chemistry, there are exceptions. Hydrogen only has to have 2, beryllium only needs 4, and boron only needs 6. Okay, everything else has to have 8. Okay, and then no lone electrons. So these are examples of Lewis dot structures that are incorrect, right, as you go through here, because they have these lone electrons. So those are all wrong. Okay, now structural formulas are really easy. It's something you need to kind of know what they are. All the structural formula is, wherever you have a shared pair of electrons, instead of like doing all the dots here, it just replaces them with a dash, okay? We're always going to kind of do the Lewis dot structure so you guys can practice it. The structural formula, just so if you see it, you just have to know that that dash just means, hey, it's those 2 electrons that are being shared between these 2. That's all that really means, okay, as you go through this. So a shared pair of electrons are ones that are being shared between, for example, the nitrogen and the chlorine, they're shared. These guys up here, notice that they're not being shared with anyone. So we call that an unshared pair of electrons as you go through. So for a structural formula, all it's doing, it's taking any shared pair of electrons, shared pairs, and replacing it with the dash, okay? Any unshared electrons, if they're on the central atom, we leave them there. And then all these other unshared ones that are around the periphery, they're not part of that central atom. We can make them disappear. Okay, so it's just a way to make a rather complicated Lewis dot structure a little bit more simple looking. Okay, so this is what it would look like, right? So I could take the water molecule there, change it to that. This would now look like that. Okay, this guy would now look like that. Okay, so just so you're kind of familiar with how that looks. All right, if you have any questions, make sure you ask your teacher.